Good morning. All right, it is a good day to talk about imaginary and complex numbers. Excited. Okay, so we've been working with quadratic equations and the quadratic formula. And as you know, the quadratic formula looks something like this. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And this thing here, b squared minus 4ac, is called your discriminant. Okay, and sometimes the discriminant is negative. And when this is negative and you have a negative under a square root, you end up with an imaginary number. Okay, so now we're going to talk about exactly how to deal with that. Okay, we introduced before that an imaginary number, a complex number is actually any number in the form. Actually, let's go down here and describe this. Let's give a definition for a complex number. Complex number is any number in the form a plus bi, where a and b are both real numbers. So your complex number is the entire thing. A is your real part, and b is a real number, but it's being multiplied by I, where I, remember what I is. I is the square root of -1. Okay, so this part here, the bi is your imaginary part, the a is your real part. So any number in the form, any complex number is in the form of a plus bi. So technically, if b is 0, then you just have a real part. So really, any real number is technically a complex number also. Okay, but a complex number is not only real numbers, but also includes numbers that are imaginary or have a real part and an imaginary part. Okay, so when we solve the quadratic formula to find zeros or to find our x-intercepts, okay, we end up with numbers that might have a real part and an imaginary part, and that's called a complex number. So just to recap, the I is just the square root of -1. For example, 5i can be written as 5 times the square root of -1, because the square root of -1 is just I, so 5 times I, or 5 times the square root of -1. Okay, so we're going to go through these. If you want, we'll go through a couple together, and you can go ahead and finish these. You can pause this. You can fast forward. I'm going to go through all 8, okay? But, so if you need the help, feel free to, stay tuned for all 8. Otherwise, feel free to fast forward and just check your work. Okay, I always break these down. Okay, take out the square root of -1. Square root of -1 times square root of 9. You can break down a square root into these two parts. This thing is your I. Square root of 9 conveniently is just a 3, and we get 3i. Okay. This one, I always start them out the same way. I take the I out. I take out the square root of -1. And now that's your I. Now this, I'm going to break it down. I'm looking for perfect squares. Well, that's square root of 49 times the square root of 2. So that's I times 7 times rad 2. And when we put it all together, we put the 7i rad 2. Okay, this is square root of -1 times the square root of 4. So that's an I, that's a 2, and we call that 2i. If you're getting the hang of it, feel free to pause, finish the next 5, and then just fast forward, see if you did them right. Okay, square root of -1 times the square root of 125. So I've got I times the square root of 25 times the square root of 5. So that becomes a 5 times an I times a rad 5. Okay. The next one, square root of -512. Square root of -1 times the square root of 512. Okay. We've got I times, I believe, 512 is 8 to the 3rd. It is. Okay, so that's square root of -1. That's an I. So this is square root of 64. Actually, we can do a little better than that. Okay, but sometimes you don't see the perfect square, the biggest perfect square off the top of your head. But for this one, we've got the 8 and the I, square root of 8. And this can break down further, square root of 4, square root of 2. Again, this isn't the only way to do this problem, but if you're doing it correctly, you're going to get the same answer. So 8I times 2, so that becomes 16I rad 2. Okay. Now this one, I usually will go off to the side and simplify this first, and then I'll put it back in. So the square root of negative 12 is the square root of negative 1 times the square root of 12. So that's I times, and that's square root of 4 times square root of 3, which gives me 2I rad 3. So I usually just in a bubble, I'll do this little part here. Now I'm going to replace it. 2I rad 3 over 2. Okay, now I can divide this by 2 and divide this by 2. Now I've got 2 plus or minus I rad 3. You can leave it as plus or minus, or you could write it out as 2 plus I rad 3 comma 2 minus I rad 3. Okay, again, I'm going to take this thing, I'm going to go off to the side and simplify that. Square root of negative 18, that's square root of negative 1 times the square root of 18. That's I times square root of 9 times square root of 2. So that's I times 3. 3I rad 2. I've got 9 plus or minus 3I rad 2 all over 12. Okay, I can reduce these. I can take let's factor out a 3 from the top. I've got 3 plus or minus I rad 2 all over 12. So now I can reduce the 3 with the 12. It's a 1 and a 4. So 3 plus or minus I rad 2 over 4. Okay. And the last one, this rad negative 22, rad negative 1 times rad 22. So I just get I rad 22. You cannot factor any further. 22 doesn't have any perfect squares as factors. All right. Okay, let's go down to the bottom. The next idea is plot a complex number on the plane. Now notice this isn't an x and a y axis, even though this graph says this. You can't plot a complex number on a real xy coordinate plane. You just can't. The xy plane is for real numbers. So we have to plot this on a plane that is the horizontal axis is your real axis, and this axis is your imaginary axis. Okay, it's almost like you think of an XY plane, and then you've got a real part, and then you've got an imaginary part, which would kind of come out of the page or in a different dimension because it's not going to exist on this plane. Okay, it's an imaginary number. So you have to kind of think outside the box when you're thinking about how to do this. So to plot this, we're going to plot the real part. And we're not plotting an ordered pair. We're just plotting a simple number. This is just one number. It's one coordinate, okay? Even though it's got a real and imaginary part. So on the real axis, we're going to go positive 2. So we're going to go 2 to the right. And on the imaginary axis, we're going to go positive 3. So 3 up, okay? So this is how you would plot the point 2 plus 3i. There's not an x and y coordinate. It's just a number, okay? So this one, 4 minus 5i. So again, that's not the x-axis. That's not the y-axis. This is your real axis. This is your imaginary axis, okay? So in the real direction, we're going to go 4. That's your a value. Remember, this is in the form of a plus bi. The a is 4, the b is negative 5, okay? So we're going to go 4 in the real direction. and negative 5 in the imaginary direction. Okay, and that's going to be the point for minus 5i. Okay, we're not going to do a whole lot more with this in this chapter. In chapter 10, we're going to go a little bit further with that. Okay, so going on to the next page, so page 102 in your packet, we're going to solve the following quadratic equation. And so this is where you're going to see what happens when this becomes really useful to do. Okay, so we're going to solve the quadratic equation using the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So in this case, opposite of b, that's going to be a positive 3 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so we get 3 plus or minus square root of 9 minus 16 over 8, which is 3 plus or minus square root of negative 7 over 8. And proper form is not to leave this as a square root of a negative. We were going to put this into I notation. So again, I'm going to go off to the right. Square root of negative 7 is square root of negative 1 times the square root of 7, which is I rad 7. Okay, so the proper way to write this answer is 3 plus or minus I rad 7 over 8. And then you would simplify if you could, but these coefficients don't have anything in common, any common factors with the 8. Okay. Now, this brings up another point. So what does this, or I, what does this equal? Rad negative 1 times rad negative 1, which is I times I. Remember, this is I, and we're multiplying by another I. What does I squared equal? Okay. Well, remember, anytime you had a square root multiplied by itself, the square root just goes away. Okay. Square root of 7 times square root of 7. Well, that's square root of 49, or just 7. Square root of 11 times square root of 11. Well, that's square root of 121, or just 11. Anytime you take a square root of something times itself, and think about what a square root means. It means like the square root of 3. What number times itself gives you a 3? Well, the square root of 3 times the square root of 3 gives you a 3. So anytime you multiply square root of something times the square root of the same thing, the square root simply goes away. So square root of negative 1 times square root of negative 1 equals negative 1. Okay, which is odd because we always said you can never. So basically you're saying x squared equals negative 1. You can never square something and get a negative number. Well, that's true if you're talking about real numbers, okay? But if you're talking about imaginary numbers, so this would mean that your I squared equals negative 1. Well, that's true because I equals the square root of negative 1, okay? So this is why this works, and that's why we say that I is an imaginary number, okay? So we're going to simplify each expression down below. When you're simplifying these, any expression with an I in it, you have to follow this pattern. You have to know this is true and how that works. But otherwise, when you're distributing with a scalar or just a coefficient, you distribute and you multiply the same way as if this were just any other number. So you distribute 3i minus 12, and then distribute this, minus 12i plus 15. Combine your like terms. So that gives me, usually it's in the form of a plus bi. We put the real part first. So 15 minus 12 is 3. 3i minus 12i is minus 9i. A plus bi, okay? And then we would simplify if we can. So this next one, we will be able to simplify. We're going to distribute that I to both terms in here. So we get negative 5 plus 6i squared But remember that I squared equals -1. So that's -5 plus 6. Oops, sorry. I forgot the I. So that's -5i plus 6i squared. -5i plus 6 times I squared, but I squared is -1. So we have -5i minus 6, and we usually write that first. So it's in the form of a plus bi. Okay? And the next one. This one we've got to distribute firsts, outers, inners, and lasts. So we've got 2 minus 3i minus 14i plus 21i squared. And be careful, we have to combine like terms, but we also have to simplify the I squared. Okay, so these two we can combine. 2 minus 17i, and then plus 21, but I squared is -1. So 2 minus 17i minus 21, and now we can combine our like terms. -19 minus 17i. All right. Okay, and then the next page, now we're going to talk about the powers of I. Okay, we just said that I to the first, well, I to the first is just I, which we know that I is the square root of -1. But we want to simplify all these in terms of I, so I notation. Okay, so I squared we said was -1, because remember what I squared is. It's I times I, which is square root of -1 times square root of -1, which gives you -1. Okay, so what's I cubed? Well, I cubed is I squared times another I. Oops, you can't see that. So I cubed, if we broke that down, that's I times I times I. I times I times I. Okay, I squared times I gives us I cubed. Well, I squared we know is -1. So we get -1 times I, or just -I. Okay. I to the fourth, well, look at what I to the fourth is. I to the fourth is I times I times I times I, or we could say I squared times I squared. That's I times I times I times I to the fourth, which is -1. Remember, I squared is -1 times -1, which is +1. Okay. Now think of what that means. I to the fourth is +1. So what do you think I to the eighth is? Well, I to the eighth is just I to the fourth times I to the fourth. 1 times 1. So that's just 1. Okay. So thinking ahead, you could say, oh, well, I imagine I to the 12th would also be 1, because that's I to the fourth times I to the fourth times I to the fourth. Remember, when you multiply powers with the same base, you add the exponents. So if 12 is a multiple of 4, oops, you could add all the 4's together to get 12. Each one of these i's to the fourth, remember, is just 1, so that's going to be 1 also. So anytime, let's say if we I to the 400, that's also 1. Because you could write this out as I to the fourth times I to the fourth times I to the fourth times I to the fourth 100 times. And it would still be 1 times 1 times 1 times 1 times 1, 100 times over, you'd still get 1. So anytime you're taking a power of an I and your exponent of your I is a multiple of 4, you're going to get 1. Okay, so that leaves us 2 in between. Well, I to the fifth. Okay, well, I to the fifth we could break down into I to the fourth times I That's I to the fifth. I to the fourth times one more I gives you I to the fifth. Well, I to the fourth is just 1. So we're going to use this idea that I to the fourth is 1. We're going to use this idea that I squared is -1. And that's going to help us to come up with any power of I. Okay? So this is I to the fifth is I to the fourth times I. I to the fourth is 1. 1 times I. We get I. I to the sixth. Well, that's I to the fourth times I to the second. Right? The sixth is just 6I. So we can break them down into I to the fourth times I to the second gives you I to the sixth. I to the fourth is 1. I squared is -1. So 1 times -1 gives you -1. I to the seventh. Well, we can take out an I to the fourth. And then we have times I to the third. I to the fourth we know is 1. Okay, I to the fourth is just 1. So that can go away because 1 times I cubed is just I cubed. Well, now remember what I cubed is. That's -I. Okay. So if you look at this pattern, I the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, you could keep going. Get I, -1, -I, 1. I, -1, -I, 1. Okay, that pattern's going to continue. So you can think about this thing on a real and imaginary plane, just like we talked about in the on the previous page. So let's say this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. This is 0, -1. Okay. So this is the real axis. So this is a value of 1. I to the fourth is just 1. That's what we have up here. Well, this is 0, 1, which means we have 1 in the imaginary direction. 0 plus 1I. So that's just I. And this over here is -1 in the real direction. 0 in the imaginary direction. So -1. And then this down here would be 0 in the real direction and -1 in the imaginary direction, so -I. And then over here back to 1. So this pattern I, -1, -I, 1. I, -1, -I, 1. I, sorry, I, -1, -I, 1. So this right here would be I to the fourth or I to the 0. And then you're counting around as you go. This would be I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. So I don't know if that helps, but that's another way you can think about these. Okay. Now, this is something that doesn't quite hold. Is it true that this is true for any negative real numbers, A and B? For any negative real numbers, does this always hold? Okay, for any negative real numbers. Let's suppose that A is -4 and B is -9. Let's plug that in. If we take the square root of A times B, -4 times -9 equals the square root of -4 times the square root of -9. Is that true? Well, if we take the square root of this, we get the square root of 36. Square root of 36 is 6. But over here we get square root of -4, which is square root of -1 times square root of 4. That's 2i. This gives you 3i. So is 6 equal to 6i squared? Well, remember what 6i squared is. I squared is -1. So this is 6 times -1. Is 6 equal to -6? Well, it's not. So this is not equal. We have to say it's not equal. Is this true? It's not, because if we multiply first and we had negative numbers underneath the radical, that negative might go away before we take the square root, and then it's fine. We can take a square root. But if we break it up, first, we can't take a square root of a negative. So this is something we always said was true, but the assumption was that this was true for positive numbers. It's not always true for negative numbers. Okay. Now, let's go down here to the bottom. We're going to practice some of these. These are interesting problems. And this is what we're going to be able to simplify powers of I. Okay? And this can get a little tricky, especially down here with a negative exponent. Okay. Now, what you have to remember is powers of I. Let's go back up here. Remember when we said I to the fourth was equal to 1. We also said I to the eighth was equal to 1. Okay, because I to the eighth can break down into I to the fourth times I to the fourth, which is 1 times 1. I to the 12th is also 1, because that breaks down into I to the fourth times I to the fourth times I to the fourth. Anytime your exponent's a multiple of 4, you can break this down into a product of I to the fourth, which is just a product of a whole bunch of 1s. I to the 400 was 1 also. So anytime your exponent's a multiple of 4, you're back to 1. Think about this pattern here. I the first, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12, 13, 14, 15, 16. Okay, you always land here on 1 if your exponent is a multiple of 4. Okay, so we're going to use that down here. Is 14 a multiple of 4? No, it's not. So we're going to break this down. What's the closest multiple of 4 without going over? Okay, so I to the 12th. I to the 14th would break down into I to the 12th times I to the second. We agree that's I to the 14th, right? The reason I did this is because I to the 12th is just 1, because 12 is a multiple of 4. This we could say as I to the 4th times I to the 4th times I to the 4th. So that's just a 1. I squared, we said, is negative 1. So I to the 14th is negative 1. Okay, so if we simply have a power of I, it's always going to end up being one of these 4 answers. It's going to be 1, I, negative 1, or negative I. Okay, unless there's a coefficient. It's simply a power of I. We're going to get one of those answers. So this answer, is this going to be I, negative 1, negative I, or 1? Okay, don't guess. We're going to use that idea. Is 27 a multiple of 4? No. What's the closest multiple of 4 without going over? I to the 24th. How many left over? I to the 3rd. So the I to the 24th is 1. So this is equal to I to the 3rd. You might remember that I to the 3rd is negative I. But if you don't, break it down further. I to the 3rd is I squared times another I. Hopefully you remember I squared is negative 1. So this gives you negative 1 times I, which is negative I. Okay. Next one. Is 100 a multiple of 4? Well, yes, it is. Okay. You could even write this as I to the 4th raised to the 25th. Okay. When you have a power, you multiply the exponents. I to the 4th is 1. So you get 1 to the 25th, and you simply get 1. Again, you don't need to do all that, just another way to look at it. I to the 100 is just 1 because 100 is a multiple of 4. What about this? Is 1,234, is that a multiple of 4? Okay, you might think, oh, that's too big a number. Or hopefully you can see that that's not a multiple of 4. Okay, but even if you didn't see it, we know that 1,200, we know that any multiple of 100 is a multiple of 4. You could break this down. I to the 1,200 times I to the 34th. I to the 1,200, that's a multiple of 4, so that's just a 1. So I to the 34th, and then this one might be a little easier to see your multiple of 4. So that's I to the 32nd. 32 is a multiple of 4 times I squared. So I to the 32nd is 1. I squared is -1, and you get -1. Okay. You have a negative I to the 75th. So let's call this negative I to the 75 is not a multiple of 4. 76 would be a multiple of 4, but that's going over. So negative I to the 72. And then we have times I to the 3rd. 72 is a multiple of 4. So this goes away. That becomes a 1. So we have a negative I to the 3rd. Okay, so we could call that negative I squared times I, which is opposite of -1 times I, which gives you positive I. Okay, next one. Okay, here we have a negative out front and a negative exponent. Okay, so look at what we have to do here. We have negative I to the -10. Well, anytime you have a negative exponent, that moves your power to the denominator. So let's leave the -1 up top over I to the +10. Okay. So we have the opposite of, or you can, if you want, think of that negative just being left out front. I put it on the top just to kind of make it easier and not deal with it being on the bottom. Okay. So I to the 10th. Let's break that down. 10 is not a multiple of 4. Call it I to the 8th times I squared. So we have -1 over, that's +1 times -1. And we end up with a +1. Oops. Okay, so you can see that -1 over I to the 10th. I broke down that I to the 10th into I to the 8th times I squared. I to the 8th is +1 because 8 is a multiple of 4. I squared we know is -1. 1 times -1 is -I. -1 divided by -1 is 1. All right. And that's all for imaginary numbers for now.